Hello and welcome to this Tech Talk. I'm Nick, developer advocate at NIL Foundation, and today with us in the studio is Alisa Cherniaeva, head of the research team at NIL Foundation too. Alisa will tell us about the Placeholder, the modular system, the modular proof system. But before, sorry, turn. Oh, okay. Something strange with the sound. Okay. Things happen. While everybody is still joining us, let me tell you a few things. First, please tell us a few words about yourself in the comments. Like, what projects are you building right now? What programming languages do you use? Are you using zero-knowledge technology in any way? And what do you know in general about zk proofs and proof systems? Second, while Alisa speaks, feel free to ask your comments in the chat. We'll answer them during the Q&A sessions. There will be 2 sessions. And finally, join our Discord to stay in touch and be the first to get to know about the new events. The link is in the description and in the comments in the YouTube chat. Come on, I want to see at least one comment from someone who is here with us. I see Ash. Yes. Hello, Ash. Hello, Brian. Hi, Alexandra. It's a pleasure to have you all here. Anyone else? Fine. Well, let's start then. Alisa, I'm passing you the microphone. Please welcome Alisa.
Hi, everyone. Yeah, firstly, I just want to add one question to Nick's. I'm really interested. What exactly you want to get from all zk technology? Why you here? What you want to achieve? I would be very happy if you waste a little bit time and write 2 words about it. Thank you. Okay, now we can start. I wanted to discuss a little bit more about Placeholder, about our modular design and all of this. So how would we speak? Firstly, we will discuss about modularity. After this, I give you some real use example, and we try to understand how we can build a circuit. After this, we will be discuss a little bit more about placeholder parameters, how we can tune it, with on. So let's go to the first topic. It's about modularity. And it just, why we call it modular proof system? Why other proof system is modular as well? Yeah, I have some simple answers. It's just because other proof system has one security assumption, one field, one commitment scheme, one lookup technique, or maybe it hasn't any lookup technique at all, and one approach how we can generate gates. So in placeholder, we have another thing, and let's just look at my examples. It's here. It's real application for all new infrastructure. And firstly, it's a Mina and Stellana state verification. It's an example of zk bridges, and it's based on elliptic cursor arithmetics. And zkDoom. It's example of zkGaming. It contains, usual game dev logic inside. So why I combined it together? It's just because it has, firstly, it's some big input, and secondly, it has some different calculation insights. So what would be set up for our placeholder? It would be custom PLONK gates. It would be big field, not trusted setup. It would be hash input verification because how I said it, big input, and lookup technique, not dependent on parent friendly curves. And let's look to another setup. It's an example of zkOracle, Lido. It's just we can prove how we can transfer information from consensus layer to smart contracts and zkEVM. Together, it's just not so big input because we can get it from some public ledger. And for more important, it's it's repeatable calculation inside. So we can use IVC PLONK arithmetization. We have small field, no trusted setup, direct input verification, and again lookup technique, which doesn't depend on parent-friendly curves. So how we can see, it's a different setup, and for now we need different proof system, or maybe we need to take one proof system and modify it, but it's not so easy to just take and modify it. So for our placeholder, we just get it. You just run it with desired parameters. So something like that. And yeah, I think it's enough presentation for now. We will return to it, but now I just want to give you some real example how we can build circuits from the source of code. We just take, for example, for now it would be mina state verification. Yeah, let's look at this. Okay, you can see it's a kimchi verifier. It's not all mina state verification, yes, because we have a pickles as well, but it's enough for today. Let's look at this. What I try to do now, I try to find which circuits we need to build. So we don't need it, and we start with Oracle function. What we have inside? Let's look at this. We have inside absorb function. It's mean what we need to Poseidon component, because inside it's generally just hash function. And for simplicity, we just call it Poseidon for now, and absorb commitment as well. And we would have some challenge function. It's Poseidon too. Yeah. We have another one function. It's, for example, would be, let's look at this. It would be PO function. Look, it's PO function. It would be multiplication component because we need multiplication. And let's go further. And it would be, it would be addition component here. Look. And it would be subtraction component. It's here. So yes, we need to build all these components to create some handy written circuits. But if we go here, you can see what we have some different linear combination. Here, here, and here we have another one, here we have another one, and here, and I'm sure what we have, and some evaluation function, another function, another combination of just simple multiplication and addition. And really, if we try to build it on ourselves, it would be not so easy. It takes much time. It can take months, and it's not good thing. It's just because we have zkLLVM. We can just, build some simple building blocks and not to go to some handicrafted circuits. We just need to find what exactly would be building blocks, and from which building blocks we can create overall circuits. So, how I said before, it would be Poseidon, it would be PO component, it would be more easier multiplication, addition, subtraction components, and I'm sure we need inverse component. Also, let me look a little bit more to this because I'm sure we would be need something else. Here. Let's look at this. We have multiscalar multiplication. Inside, it would be divided on variable-based multiplication and end-of variable-based multiplication. But for simplicity, let's think about it as just variable-based multiplication. Yes. So let's say I watched all file just to be sure what we didn't miss anything. Yes, it's okay. That's all. So yeah, now let's recap all these things. You just start. What we have like a building blocks for compiler. Always remember it's Poseidon component. Second, we have PO component. And for really big components, we have variable base multiplication. And for more simple components, we have multiplication, we have addition, we have subtraction, and the inverse component. So it's just 7 components, and we can express all this big file just from these 7 components and get overall circuits just in, I don't know, just in minutes. If we try to do it on ourselves, it would be month. So yes, I really like this thing, and our compiler is just a way to get it more quickly. But it's a question now. For now, would be with circuits as much powerful like just human created? Yeah, let's think about it. For now wanted to return to our presentation and think about circuit parameters. What we think about it? Firstly, it's columns, it's rows because it's just a table with column and rows. We care about total amounts of gates. We care about gates degree and lookup option. Turn on, turn off. Yeah. So for now, we will focus it more on the columns parameter and about total amounts of gates. Just remember it, and let's return to our drawing. Yeah. So we have mina state verification for these 3 components, and it's have some complex computation inside. So let's imagine what we created for 15 columns. It's just example. And it's pretty obvious what it would be 3 columns. And for inverse, it would be 4 columns. Yeah. So let's try think like if we would be use some naive compiler approach, how would be looks our assignment table? Let's take some shape and let it would be a block for Poseidon, for PO, and variable-based multiplication because it has the same number of columns. Another block would be for multiplication, addition, subtraction. And a little bit more for our inverse. Something like this. Yeah, good. So it would be better, it would be boring if we just take for one of the subconus. Let's think about like it would be x3 and x2. Yeah. So, okay, here we have Poseidon component, we need to have PO component, and the last one, it would be variable base. It would be better. For multiplication component here. And the naive approach would be just looks like this. Multiplication, multiplication, multiplication. After this, addition and addition, addition, subtraction, subtraction, and subtraction. 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, and for true inverse, control. Inverse, and the last one, inverse. And just look at these things. How it would be assignment table looks inside. It would be just with one. It would be the same like Poseidon components. And here we would be have empty spaces. And it just little shortcut for now, but just imagine if we would be take it, I don't know, 1,000 times, and we would be have many empty cells inside the assignment table. So it means we would be have bigger polynomials. Bigger polynomials would be influenced in gate argument. So how we know it? Gate arguments, it's a biggest part of for performance, and if we just take with one component, with one result circuit, it takes much time to generate a proof. Yeah, I think you could say what we can create it in another way. Let's say what it's just like smart approach for compiler. It would be the same for Poseidon, PO and variable-based component. Just because we designed it specially for Mina, so it's the best components handicrafted. So the same beginning, and look at this part. So what happens? Multiplication, another one multiplication, and last multiplication. Subtraction, subtraction, and last subtraction. Addition, addition, and addition. And we have three columns, and we cannot to get it inside our inverse component, so we need to locate it in another row. So it would be like that. And here overall assignment table would be like this. Here still empty spaces, but it's much less than before. But let's look at this. Each component, it's different gate. Each different gate generate their own selector column. So really, it would be another one selector column, another one selector column, another one, and last selector column. So for each new gate which we create. And honestly, it's a not smart approach for compiler. It just have the same, it just have drawbacks, but it's a different side. So in the end, we have much worse circuits when just human can design it. But for now, I suggest you to use flexible gates technique. If I try to explain it In some simple way, it would be just avoid all intermediate variables and push it into one gate. Let's look how it would look like. So take the same beginning. How I said, it just was created especially from Mina, the best components. And last one. So how I said, we try to remove all intermediate variables. What does it mean? In multiplication, addition, subtraction, inverse components, we need to delete two variables. Also, we need to use two inputs and one output. For simplicity, let's think about like sequential calculations. So let's try to write it. It would be two inputs, and with two inputs would be just for first multiplication. After this, we have multiplication, multiplication, addition, 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 subtraction, 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 inverse, inverse, in output. So let's try to calculate it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 14, 15. It's the same size. So, and how I said, we need to push it into one gate. No empty spaces, just one gate. Yeah, it's like example, and in this example we get in result just one gate, and in this example it would be much more. It would be 4 gates, and in this example it would be 11 gates additional. But you can just imagine it. The human would be created with circuits with one, and flexible gates would be created automatically, and it just in few seconds. So let's return to our presentation, and I just want to go more formally about flexible circuits technique. So what would be first? Firstly, we have some metric function which evaluate all gates assignments, and it's really matter what parameters we get in result from this metric function. When it's evaluated, we return to compiler work, and it's create overall circuits. And with circuits, insights will be request to our building blocks like Poseidon, POW components, all these things, and this will adapt to chosen parameters like here. And another one interesting detail, just return me please to my drawing. Yeah, thank you. And let's return to our list of components, and let's think about, for example, DOM, state verification. How I said, it's just a usual game dev logic, so we would have arrange check component. We would definitely have some Boolean components. We would have, for example, shift component and POW component. We can take from another circuit designer who created, for example, 4 9 columns. And we don't need to take the POW component and create it again. We just take it from our Mina state verification. And it would be without flexible gates, just compress into 9 columns. This circuits would be this much powerful how it can be. Yeah. Yes, I think it's time for a little bit break. And I see your questions, and I will answer for them. After this break, I will return with another part of presentation.
So yes, a small break. Thanks for being with us. Let's just look at the questions that we have so far. I see that. Oh yes, the discussion is already going on, so people are helping each other in the comments. Just look at it. That's beautiful. We have questions from Vivek, and Sergey is answering it. I'm sure Alisa will come back and give more elaborate answer. But yes, great. While we are there, is it not the first Neil event for any one of you? I remember Ash in the commands. So has anyone else been with us already? Okay. I don't see any commands yet. Well. Oh. Yes, and another one from Ilya, from Neil. He's also secretly here with us today. So let's get to our first Q&A session. Welcome back, Alisa.
Yeah.
And I think we'll join Ilya just in case. Hey.
Hey.
Guys, head of the protocol team. Well, let's start with this one. So, Lisa, could you please tell us more about the assignment tables? What's it? You can draw
Yeah.
if you want.
Yeah, it's Sergey says always right. It's just like a witness in Zircom, but we have not only witness. We have another type of columns. It's like public and some constant columns. So it's just some trace of all calculations. I hope you understand me.
What if people are not familiar with the notion of witness? Just the basic what's an assignment table used in Placeholder?
Yes. So it's separated into parts. One of it is just prover note about it, and another one I said about like public input columns, like constant columns, selector columns with type of columns. It's and prover and verified know everything about it. So it's just the values.
Yeah, great.
Basically, yes,
we can see.
If you mind, yes. Basically, yes, it contains all intermediate calculation results. So each step, then we are going through the algorithm. We just put one value by another into this table to check it later.
Great, thanks. Now that's another one question from Ash. Thanks. What are the key takeaways or benefits that a developer and the blockchain community can gain from using Placeholder? I think that's a very general one.
Yes. Could we return it after the second part of my presentation, because I will have some answer for this.
Return to this question after. Okay, I've noted. We will return to it. There's another one about working examples, and I think it also goes after because you will be talking about particular use cases.
No, I can answer it now because yes. I just wanted to clarify one thing. You mean you want to see some examples of flexible circuits, yes?
Well,
Because
let's answer both
yeah.
questions.
Yeah. Because if you mean some result circuits, you can go to and watch for Mina state verification and Solana state verification. We have already have it. And for example, for flexible gates circuits, and it would be really interesting for you, but it's all sub circuits for zkGaming. It's a shift, it's Boolean components, it's power components, all of this thing we have already. It's in in flexible way.
Great. Oh, there's a for zkLLVM. Do you guys need to extend LLVM's IR in any way? Or just use LLVM extrinsic? Well, let me try to answer this one. We are so zkLLVM is based on LLVM and using its own internal representation. I think we have to make some extensions to makes special syntax for circuits parsed by the compiler, but the most work goes in well, on the other side, where we compile the code into circuits. That's yeah. Okay. We have very helpful viewers today. Sergey is answering. So yes means we need to extend it, I guess. What else? What else? What else do we have here? Okay. Well, I think that's all. I have a few questions myself, but I will save them for the next session. Are you ready to continue?
Yeah.
Okay, fine. Let's go. Slides or the picture? Alice, slides or?
Slides, yes.
Okay, fine.
And really, here would be answers for question what I saved for later, so you can just hear it about now. Yeah. What we can tune inside the placeholder parameter, because flexibility in building circuits, it's not enough for us. We try to make flexible all our own placeholder. So first of all, if you remember, let's say just we have something about big field and small field, and what I mean about it, it just for example, sometimes we have elliptic curve arithmetics and we need a big field, and in another case when we just work with integers, we can use some small fields. It would be the second option. And our circuits will adapt to chosen option. And if it was just one element, just one cell in assignment table, it would be just array of cells. Or it switch back and it would be just one cell. It's okay. Our components can do it. As a second option, it would be choice of lookup techniques. And all approaches now is divided on two. One of them is depend of the main table size, and the second one doesn't depend of the main table size. Yeah, it sounds better when it doesn't depend of main table. For example, it's a lookup, baloo. But we have some drawback here. We need to use field of pairing friendly curves, and it's doesn't good sometimes for us. For example, it doesn't suit for Mina, it doesn't suit for Solana, and even Doom. Yeah. And the second approach, which depends on main table, it's a little bit worse, but we can use it always. So it's just like PLONK up, lookup, and Halo to lookup argument. Maybe you hear something about it. Also, we offer some flexibility inside lookup tables. Okay, we have some result circuits from our compiler. If it would be big circuits and we would have some small lookup tables, we can compress it into one physical columns, several lookup tables. And another case, when we get some small result circuit, we can split it into several columns. So our lookup constraints would be like with value contains in first column or second column or n column. It doesn't get some overhead for prover work, so it's just some inner option. Okay, after this, yes, of course, we have a choice of commitment scheme. If you don't like trusted setup, you would be use LPC option, and it would be friend side. Yeah, it have not so cheap verification, but if you don't care so much about prover work, you can switch on grinding option, and it would be better. Also, we have some universal trusted setup. It would be option KZG. It have cheap verification, but yes, you need just make your choice. Also, we have some flexibility inside choice how we can generate gates. First of all, we have IVC PLONK constraints. About IVC, you can hear when you read about something nova, supernova, hypernova, maybe it would be cryptostar. But I really doesn't like just take R1CS and Nova. I think it would be better to use like in Protostar IVC plus PLONK constraints. So it now in work in progress, but I believe to the end of year we have implemented it. Will implemented it. So is a second option. It's a custom PLONK gates. And of course, also we have recursion support if you need it, and EVM verifier. Okay, let's give you some examples about it, how we can choose with parameters. Firstly, we look at the Mina circuits. We build Mina circuits. So just try to think about how we can prove what we would be tuned in overall Mina state verification. Inside Mina use pasta curve fields, so we need to separate it into two parts. First one would be on the Palace field, and second one would be on Vesta field. Palace Vesta, it's a curves, pasta curves. We don't need any lookups. We don't need trusted setup. And how you can see in the source of code, it wouldn't be repeatable calculations. So we need to use custom PLONK gates. And we don't need any recursion because it fits to 2 in power 23 table. So it just would be one table. And another side, you can see Solana state verification. Solana use YD field, and it's not good even for KZG, no for Fry, so we need to have non-native arithmetics. And as we have non-native arithmetic, we can choose what we like. And in our case, that it would be Palace field, because modulus of Palace fields would be bigger than modulus of YD. How we use non-native arithmetics. Also, we use hash function, which is not circuit friendly. we need to have several lookup tables, and it would be better to use general lookup technique. We don't need trusted setup. We would be use custom gates. Why will we use custom gates? Yes, we have some repeatable blocks because we have 1,000 validators, but it's big block, and 1,000 it's not so big amount of repetitions, so it would be better in this case to use custom gates. And how I said, in the Lido case, we have just a Merkle tree and 5 millions of hash function. So in this case, better to use IVC approach. And how I said, it would be 1,000 validator, each has their own signature, and the signature with non-native arithmetics. So we need recursion support to separate it into 2 circuits and bring them together. And it's also give us one detail. We avoid lookup argument verification. So we get cheap verification like for monostate verification. Yeah. Yes, I think I told everything what I want. Thank you for listening. And I'd like to ask for your question again.
Hello again.
Give answers.
Yeah. On the screen is a QR code. Guess what's there? The link to our Discord. Please join us. And we have a few more questions. Now, the one that we saved for later is from Ash.
Yeah, how you can see it, we have many options to build application on the top of this folder. You don't need to modify anyhow another proof systems. So it would be benefits. You don't need to think about another setup. It just could be easily, you just tick one option, another option, and you get a result.
Yeah, so I think this question has two levels, 2 layers of answer. First one is about zk technology overall, like what are the benefits of using anything zero knowledge in the blockchain? And the answer is generally, well, it's the future of the blockchain, and it can solve many problems which are not solvable with the current technology, relying on trusted oracles and such. And well, among other proof systems, the reason for picking Placeholder is like Alice just said, that it's modular, and you get to pick the variables, the parameters, to flexibly build your application to its business requirements. And when they change, you can then change the setup. Am I right, Alisa?
Yeah.
Okay. And that leads to my question. I will abuse the power of being the host to ask my own question. So if I build an application and I pick certain configuration parameters, how difficult will it be to change them in the future when the business requirements change? Like I need more security, or I need to reduce the speed. Reduce the time, increase the speed, or anything else. What will I do? How complex will it be?
So it would be firstly, you just need to think about what you need to get in results. And often it would be for first one goal, you need to know trusted setup, you take LPC, you take some custom PLONK cache gates, it works good for now, but after this you understand you don't need trusted setup. Not, I mean, you can use some light trusted setup. You can afford yourself with one. So you just switch into KZG option, and I don't know, it maybe takes 5 minutes, maybe more. You just need to rebuild your setup.
Precision.
It's
I
all.
mean, just recompile it
Yes.
with zkLLVM. Don't I have to rewrite the code?
No.
Okay. Indeed. Wow. Any more questions? We have one from Sergey.
Mm-hmm.
It's more of a idea.
It's not so easy question because I need to think about it and try to imagine what I can say for now. If you have me,
Well, you're thinking I have one quite general idea. Like as always, it's bad to do premature optimization. So placeholder allows you to flexibly change parameters, and like it would be a bad practice to abuse this. Like I know that security is good. I want like super top absolute maximum security. I want like I don't know, the bits of complexity above anything that my application will ever need for security, and then I will have a very like proofs that are very heavy.
We don't have some bad example really, but we can have bad zk app developer, and it's just, I don't know, want to create some application which would be have insights, I don't know, just multiplication, and something like Kichak. Let it would be Kichak, and some design of Kichak which will be used, I don't know, maybe it would be used 150 columns. And in this case, we get some good assignment table, but it would be best because we would be have definitely much more witness column that we want. But it's just I try to, yes, it's just some inner components. It's about some real use application. If I remember something, I will write you. Definitely.
Yeah, cool. Thank you. But please don't call developers bad. I mean, they can make mistakes, but our job here is to help them not make these mistakes. So, don't go over optimizing one of the parameters. And when you're in doubt, just come and talk to us in our Discord, in our Telegram. We will be happy to help review your architecture and the technical decisions that you're going to make. Well, what else do we have? Come on, folks. Time for one last question. Oh, yes. This one. Didn't we skip it?
Yeah, I have already answered for this question.
Oh, okay, yes, we just can remind that we have this. What we have this in implementation. Mina State, Solana State. We have the project with Lido, zkOracle going on. So stay tuned and get to know when things get released. Well, maybe now it's time to say thank you to everyone who has been with us today. Thanks, Alisa, for this journey into the depths of placeholder proof system. It's been very enlightening, although hard sometimes. We hope to see you again. And so,
Nick, stop. We have another one questions, and I think you could answer for them.
Yeah, I like this. Well, what were the primary motivations behind the development of Placeholder, and how does it fit in the broader goals of the NEAL Foundation? Well, yes, a nice one. So we are building an infrastructure and ecosystem of products for building zk applications, and we have everything zk developers need on every stage of from developing and testing applications to launching them into production. Just picking some available proof system, or just implementing something that's that wouldn't require research from us, would make our ecosystem inflexible. I mean, not suitable for building all the zk applications that can be made, and that's opposite to what we are going to do. I mean, what we are building, we want our tools to be applicable to practically any zk solution. So we need a flexible modular proof system, and it means that we need to do our own research, to have the team which does this research, and Alice here is the head of this team, and we have worked on Placeholder for a few years already, and still continuing the work. All that to give you the best tools for your job. Just like that.
Yeah.
Thanks for the question. Well, it's been a pleasure to have you all here today. Thanks again, and goodbye.
Goodbye.